totally gonna get one. Man, I wonder where they put them.
Oh yeah, look. A map.
Hey, there's 2 copies. Just give me that one link. Hey, we're at Eaglewood Park. Want to follow it? Sure. Let's go. Here we are on the map. First stop is the Pavilion of Peril.
That sounds really scary. Are you sure you want to go there?
I'm sure it'll be fine. Let's go together.
So we found a camera, so we decided to record ourselves just in case we died. Anyways, so here we are, the Pavilion of Peril.
It's not very perilous.
I know, seems a bit of an over-exaggeration. Let's see what we got. Ooh, it looks like a couple problems. Can you read it?
It says, find where the graph of the function f of x equals 1/2 x to the 4th minus x cubed minus x squared plus 3x plus 2 is both increasing and concave up.
Oh.
Here's the graph here.
That's convenient. Okay. Well, I don't really remember how to find out if the graph is increasing. Can you explain it?
Yeah, I think it's when the first derivative is positive.
But how do you find that from the graph?
Well, the first derivative of a function is also its slope. Here's the graph of the function. So we're looking for where the graph is increasing, which means that its slope is positive. So as you can see, from this purple line here, the slope of the graph is positive all the way up until this other purple line here. And then from the blue line to infinity, the slope is then positive again.
Wow, that makes so much more sense. Could you please stop?
Next, the problem asks about concave up. What does that mean?
Oh, I remember. Let me give it a shot. So, concavity refers to the second derivative, in which if the second derivative is positive, it's concave up, like a smiley face. And if it's negative, it's concave down, like a sad face. So we can see here that at this point here, the graph is like a smiley face, and therefore it's concave up. And here too, it is also concave up. The points where it switches from concave up to concave down are called points of inflection. And that is when the second derivative is 0 or undefined. So the question asks where it is both increasing and concave up. Well, like you told us, Adeline, the graph is increasing from this purple line to this purple line, and from this blue line to infinity. So that must mean it was concave up and increasing from this purple line, x equals negative 1.012, to x is negative 0.6, and also from x is 1.14051 all the way to infinity. Doesn't look all that horrifying.
Oh no, on the map it says caution, dangerous creatures. Children.
Oh my gosh, there's a whole herd. Let's just find our next clue. Oh look, there it is. Find the intervals where the function g of x equals 2x cubed minus 2 times x plus 1 is increasing and decreasing. I forgot increasing and decreasing again. Can you explain it?
Yeah, so it's where the function's slope, or its first derivative, is positive for increasing or negative for decreasing.
Okay, so how about you solve it?
Yeah, let's try it out.
That's convenient.
So to find the function's first derivative, we could use the product rule and multiply this out, or now let's take the first derivative using the power rule. Okay, so now we have to set the first derivative equal to 0 and solve for x. And when we do that, we get x equals 0.45541. So now we will look at this interval and see what's going on either side of this point.
That's called an interval test, right?
Yep, that's right. So, if we plug in a number like, say, negative 10, then we will get a negative number when we plug it into the first derivative. And then if we take a number that's larger than 0.455, such as 2, then we will get a positive number. So that means that this function, g of x, is decreasing from negative infinity to 0.45541, and it's increasing from 0.45541 to positive infinity.
So next it says we're going to the structure of slippery slopes. It's just slides.
Just slides.
Let's go! This problem says to find the points of inflection of the function h of x equals 1/2 x squared minus x cubed minus x squared plus 3x plus 2. That looks familiar. And show the intervals on which the graph of h of x is concave up. So the first thing to do is to take the derivative of h of x, which would give us the slope. So when we do that, we get that h prime of x, this is really hard, equals 2x cubed minus 3x squared minus 2x plus 3. But we want to find the points of inflection, or the places where concavity changes. And in order to do that, we need to take the second derivative. So the second derivative we're going to find using the power rule. And we get that h double prime of x equals 6x squared minus 6x minus 2. So to find the critical points, we need to find where the second derivative equals 0. So this right here equals 0 at x equals the negative square root of 21 minus 3 all over 6, or square root of 21 plus 3 all over 6. Or the decimal approximation would be negative 0.2637 or 1.26376. So a lot like you did with the first derivative, we're going to use an integral test or the second derivative test. We're going to find when the second derivative is positive and negative. So we're going to plug in a number smaller than negative 0.2637, like negative 100. And when we do that, we're going to get a positive number, meaning that it's concave up. And so we're going to plug in a number between negative 0.2637 and 1.26376, like 0. When we do that, we get a negative number, so it's concave down. And so then we're going to plug in a number that is bigger than 1.26376, like 100. We're going to get a positive number. So as shown by the second derivative test, this function h of x is concave up from negative infinity to negative 0.26376, and it's concave down from negative 0.26376 to 1.26376, and concave up again from 1.26376 to positive infinity, which means it probably looks something like this. The last spot says, your worst enemy?
I don't know. The last three were over-exaggerated. They weren't scary at all.
I don't know. Let's see. Is that College Board? Oh my gosh.
It was right.
That's insane. What's that? Oh my gosh, it's the 5.
It's the 5! We found the 5!
We'll have to rescue it. It's gonna... We did it! Now you can get your 5 on the AP exam that we took last week.
This video is not affiliated with, endorsed by, or approved by College Board or College Board Associates. No 5s were harmed in the making of this film.